Please look at the picture. Discuss with the people around you, what could all of these have in common? What conclusions or judgments can you make about these pictures? What do you notice about this? What shape does it make? What shape does this array make? What kind of patterns do you notice? What do you notice about one group of one, two groups of two, three groups of three? What do they all make? Pause the video and discuss with your team. Once you are done, start it again. Okay, today we will review factors and products and how they work together. Now, to remind you, a factor makes a product. The product of 2 and 3 is 6. These factors are the factories that make the products. We will also investigate arrays to find perfect squares. An array is a diagram of a multiplication sentence. This array shows 2 rows of 3. Now, if you notice, this array does not make a square, so we will come back to that. We will also interpret or figure out how to identify perfect squares. Well, when you look at some arrays, some will make a square. We will also work together and have grit. So I would like you to draw 3 rows of 3 with 3 X's in each row. Pause the video and discuss what that would look like with your team. Okay, so I drew 3 rows of X's with 3 in each row. I have 3 rows of 3. Well, we know any number times itself then would have all sides equal because there's 3 on every side. And what I know about squares is they have equal sides. All sides equal. All the sides equals 3. That means this makes a perfect square. Well, 3 has other factors. One group of 3 also makes the product 3. What do you notice about this shape, though? Do the sides all equal? This looks more like a rectangle. So this is not a perfect square. This is because 9 is the product of 3 groups of 3. This array makes the perfect square 9. Because it's 3 rows of 3, the product is 9. It makes a perfect square. How else can you find perfect squares? Well, one group of 1 has a product of 1 and has 1 on each side. Each side is equal to 1. That means the product 1 is a perfect square. The product 2, well, what makes 2? The product of 2 is equal to 1 times 2, but my array would not make a perfect square. The sides are not all equal. So 2, the product 2, is not a perfect square. What about the product 3? 1 times 3 equals 3. If I was going to draw an array, it'd be 1 row of 3. Does the product 3 make a perfect square? Again, doesn't look like the sides are all equal, so that would not work. What about 4? The product of 4. Now there's a couple ways to make that. I could do 1 times 4 or 2 times 4. I mean 2 times 2. Both are equal to the product of 4. Discuss with your team, pause the video, and think about which one makes a perfect square. one group of 4 would be one row of 4. That does not have equal sides, and it makes a rectangle, so that would not be the array that shows a perfect square. However, if you did 2 rows of 2, your product would be 4. And what do you notice about your sides? The sides are all equal to 2. So 4 is a perfect square, but the reason it is because the factors 2 and 2 make it so. What other factors make a perfect square? Pause the video and discuss. Well, 3 times 3 would make a perfect square because all sides are equal. Each side is equal to 3. 4 times 4 would make a perfect square because 4 rows of 4 has all sides equal in the array. That would make a perfect square. And what is the product of 4 times 4? 16. So 16 is a perfect square. And 3 times 3 equals 9, and 9 is a perfect square. 16 can be made with 2 rows of 8, but that is not a perfect square. The reason 16 is a perfect square is because one of the factor pairs make it a perfect square. Okay, now please find more perfect squares. Remember this chart? Pause the video and talk to your partner about how this shows perfect squares and what patterns you see.